So welcome back, my dear friends. Let's continue. If you see in the last session, we have completed central tendency line. In this session, our target will be to complete dispersion. Okay. We'll complete dispersion and we'll complete all the sums related to dispersion in this session. Now, if time permits, we'll complete everything, or else one, two things there, here, we might have, we may leave. That is, we'll cover it in tomorrow's session. Okay. So if you see, my dear friends, first we understood what is the meaning of dispersion, right? Dispersion means we are trying to calculate a deviation of observations from the central tendency value. To calculate deviation of observations from the central tendency value, we call it as dispersion. It is also called as measures of deviation or measures of spread or averages of second order, right? Next, I said we are having two types of dispersions: absolute measures of dispersion and relative measures of dispersion. In absolute measures of dispersion, what's happening? We are trying to calculate the dispersion in terms of units. In case of relative measures of dispersion, we are trying to calculate dispersion in terms of percentages or numbers or degree, right? Next, I said what we'll be using for a comparison, absolute or relative measures. Obviously, sir, we'll be using only relative measures for comparison. We don't use absolute measures for comparison. However, if the units are similar, fine, you can use absolute measures for comparison. Next, I said we are having two positional measures, two algebraic measures. Range and quartile deviation are positional measures. Mean deviation and standard deviation are algebraic measures, right? Yeah. Next, after this, I said degree of variation is relative measure, amount of variation is absolute measure. Then we went ahead and we started with range. I said in range, we calculate the difference between lowest observation, so largest observation and smallest observation. Let it be individual data, let it be discrete data, or let it be continuous data. Formula will remain same. There is no change in the formula. Next, I said range is used in industries and profit calculation. And next, I said for range of frequency of distribution are of no use. We have seen some examples for that. Fine, everybody, till here it's clear? Now, okay. So, my dear friends, let's continue. So, we have seen the concept of range, right? Now, before going to quartile deviation, mean deviation, and standard deviation, let us understand some properties of dispersion. Okay. So you'll understand there's a little difference between central tendency and dispersion today. Okay. Now, properties of range / dispersion / quartile deviation / mean deviation / standard deviation. The properties what I'm teaching you now are same for all the four things. Okay, there is no change. The properties are same for the entire dispersion. Okay. First property, if all observations are constant, that is same, dispersion will be equals to 0. Okay, like say for example, I'm having 7, 7, 7, 7. Allow for a reason. Example. What is the range in this case? Highest observation is 7. Lowest observation is also 7. Range will be equals to 0. So if all observations are same, entire dispersion is equals to 0. I'm having 10, 10, 10, so on, 999 times. Even in this case, my dear friends, range or entire dispersion will be equals to 0. If all the observations are same, dispersion will be equal to 0. That's it. Okay. If all observations are constant, central tendency is constant. If all observations are same, dispersion will be 0. Next. If all observations are increased or decreased by constant, there is no change in dispersion. If all observations are increased or decreased by constant, there is no change in dispersion. Say for example, my dear friends, I am having 5, 7, 9. What is range? 9 minus 5, which is equals to 4. Now all the observations I am increasing by 5. 5 plus 5, 10. 7 plus 9, 13, not 12. 9 plus 5, 14. What is range? 14 minus 10, again it is same 4. So can you see when all the observations are increased or decreased by constant, range didn't change. Range will remain same, unfortunately. Okay, next. You remember what is this called in statistics? Increase or decrease by constant? I hope you remember. We call it as change of origin. So I will say dispersion is not affected by change of origin. Only central tendency is affected by change of origin. Dispersion is not affected by change of origin. Next, third point. If all observations are multiplied or divided by constant, then dispersion is also multiplied or divided by same constant. Okay, if all observations are multiplied or divided by constant, then dispersion is also multiplied or divided by same constant. See, there's a little lag in the screen. Okay, no. Like say for example, same let me take 5, 7, 9. Range will be 9 minus 5, which is equals to 4. Now all the observations are multiplying by 3. Okay, 5 into 3, 15, 7 into 3, 21, 9 into 3, 27. So range will be 27 minus 15, which is equals to 12. So can you see, even it got multiplied by 3, 4 into 3 is 12. So I will say one point, my dear friends, here. Dispersion is affected by scale and not by origin. So I hope you people accept this fact. Okay, if all the observations are increased or decreased by constant, so dispersion did not change. That's the reason I said it is not affected by origin. But when all the observations are multiplied or divided by constant, dispersion also got multiplied or divided by constant. That's the reason I said it is affected by scale. Okay, so I hope the point is clear. First 3 points. Now, how the implication of this point will be there, I'll let you know now. I'll give you a few sums also, which we'll solve now in the class. Fourth point. Dispersion cannot be negative. Dispersion cannot be negative. My dear friends, dispersion can never be negative. Unfortunately, dispersion can never be negative. Remember this. I'll tell you why. Like say for example, I'm having 5, 7, 9. What is range? 4. I'm having minus 5, minus 7, minus 9. How will you calculate range? Highest observation. What is highest observation here? Minus 5. What is lowest observation? Minus 9. So minus 5 plus 9, which is equals to 4. So can you see if all observations are negative, did your range change? No, range, sorry. Is your range negative? No. Next. Minus 5, minus 7, 9. The range. Highest observation minus smallest observation, which is 9 plus 7, which is equals to 16. Can you see, my dear friends? If all observations are positive, dispersion is positive. If all observations are negative, dispersion is positive. If some observations are positive and some observations are negative, still dispersion is positive. Okay. So can you see dispersion cannot be negative, it will be positive only. Okay. These are the 4 very important points in dispersion. First, if all observations are constant, dispersion is 0. Next, if all observations are increased or decreased by constant, dispersion is not increased or decreased by constant. If all observations are multiplied or divided by constant, dispersion is also multiplied or divided by constant. Dispersion can never be negative. Final answer, cannot be negative. If it comes negative also, you apply modulus and make it positive. Okay. Now, say for example, I'm saying 1, 5, 7, 9, 11. What is the range? 11 minus 1, 10. Okay. All observations I am multiplying by 2. So what is range? Obviously, sir, if all observations are multiplied by 2, range is also multiplied by 2, 20. All observations I am increasing by 5. What is range? Range will not change, sir. Range will remain same. All observations I am reducing by 50. Range will remain same. All observations I am adding by 999. Range will remain same. Okay, because range is not affected by scale and origin. Now, if you remember in yesterday's class, no, not yesterday, day 4 yesterday's class, I said you this. In linear equation, ax plus or minus by plus or minus c equals to 0. This a and b is getting multiplied with x and y. So I said you they are scale. This c is getting added or subtracted. That is called as origin, right? Since dispersion is not affected by origin, while solving a linear equation, you will not take this c. You will solve the sum taking only ax plus or minus by. Let me give you an example. Range of x is equals to 5. Find range of y. Relation is 5x plus, let's take like this, 4x plus 5y minus 9 equal to 0. Now, what I said you, my dear friends, in central tendency, put the value, get the answer, right? But here, that's not the case. Okay. You will not consider this constant. So you'll do 4 into 5 plus 5y equals to 0. 20 plus 5y equals to 0. 5y equals to 20. Y is equals to 20 by 5, which is equals to, sir, minus 20, right? No. 5y is equals to minus 20. No, please don't do that, because range cannot be negative. Dispersion cannot be negative. Final answer cannot be negative. Be careful, my dear friends. Okay, I hope you understood this. Let me give you one more example. Quartile deviation of x is 7. Find quartile deviation of y. Relation is 2x plus 4y minus 65 equals to 0. What you'll do, will you consider the 65? No. So instead of x, I'll substitute 7. 2 into 7 plus 4y equals to 0. 14 plus 4y equals to 0. 4y is equals to plus 14 or minus 14? Plus 14. Y is equals to 14 by 4, which is equals to 3.5. So quartile deviation of y is equals to 3.5. So I hope, my dear friends, this concept is clear. I will summarize the entire concept. See here once. Central tendency, dispersion, mean, median, mode, range, quartile deviation, mean deviation, standard deviation. So first point, if all observations are constant, central tendency is constant, dispersion is 0. Next, if all observations are increased or decreased by constant, that is origin. Yes, central tendency also increased or decreased by same constant, but dispersion, no effect. Next, if all observations are multiplied or divided by constant, scale, central tendency is also multiplied or divided by constant, dispersion is also multiplied or divided by constant. Next, negatives. Can central tendency be negative? Yes. Can dispersion be negative? No. Next, ax plus or minus by plus or minus c equals to 0. Put the value, get the answer. Here, ignore constant, comma. Final answer cannot be negative. Okay. So I hope it's clear. There's a relationship between central tendency and dispersion. I'll give you guarantee, my dear friends. I'll keep a bet of 1,000 rupees. Compulsory, you'll find one question in the examination on this concept. Without question on this concept, there is no question paper till now. Take any question paper of past 10 years. Pakka, you will find one concept of what I have written here. From this table, first sure you will find out one concept. Okay. Now, if you are writing anywhere, please make sure that you will note down this. I'll give you some questions now. What you do, just go ahead and solve those questions and tell me the answers. Okay. And make sure that you will get a correct answer. If you get a wrong answer also, there is no issue. You can tell me, I'll help you with those answers. Sure. See these examples. I'll write few questions, solve them and tell me the answers. This is the most important concept in dispersion. Okay. Because first sure you are going to have a question. I'm saying 3x plus 4y is equals to 20. Quartile deviation of x is 12. Calculate quartile deviation of y. Next, 2x plus 3y plus 4 equals to 0. Standard deviation of x is 6. Calculate standard deviation of y. Five y minus 3x is equals to 10. Mean deviation of x is 12. Find mean deviation of y. Solve all. Please solve the 3 and tell me the answer. So I hope you have solved them. Please check your answers only after solving them. Now, what I'll do, I'll simply instead of x, I'll substitute 12. 3 into 12 plus 4y equals to 0. 36 plus 4y equals to 0. 4y is equals to not minus 36 plus 36. Y is equals to 36 by 4, which is 9. Next. Will I consider the constant? No, I won't consider the constant. 2 into 6 plus 3y equals to 0. 12 plus 3y equals to 0. 3y is equals to plus 12, not minus 12. So y is equals to 12 by 3, which is 4. Next. So 5y, will you consider 10? No. Minus 3 into 12 equals to 0. 5y is equals to 36. Y is equals to 36 by 5. This simply equals to 7.2. Okay. So I hope you got these 3 things. Next. So that's all regarding range. With this, we are done with first dispersion. Range, coefficient of range. Range, highest observation minus smallest observation. Coefficient of range, highest minus smallest divided by highest plus lowest into 100. Next. Now, my dear friends, let's get into quartile deviation. Now, you already know how to calculate quartiles, right? Individual data, discrete data, and continuous data. Individual data, how will you calculate quartiles? First, you will arrange the data in ascending order. After arranging the data in ascending order, you will apply the formula J into n plus 1 by 4. J will be the quartile what you require. N will be the number of observations. Okay. Now, j into n plus 1 by 4, will it give you the answer? Unfortunately, no. Will not give you the answer, right? So when it doesn't give you the answer, what you will do? You will get a location. Go ahead, locate it. Okay, in the data, in the Google map, you locate it. You will get the respective answer, right? So that's how you will calculate quartile 3 and quartile 1. Next, how will you calculate in continuous data? In continuous data, first you will do LCF. Okay. After doing LCF, you will simply go ahead and you do jn by 4. This jn by 4, using this jn by 4, you locate it in the data. Okay. After locating in data, you will apply the formula L plus jn by 4 minus cumulative frequency of previous class divided by frequency of same class into class interval. That's how you will calculate quartile 3 and quartile 1, right? Now, what is this quartile deviation? As a word itself says semi-interquartile range. Now, you know we have 3 quartiles, quartile 1, quartile 2, quartile 3. Among these 3, quartile 3 is the highest, quartile 1 is the smallest. Okay. Semi-interquartile range. What do you mean by semi? Half. How will you get quartile range? Highest quartile minus lowest quartile. Q3 minus Q1. Okay. So this would be your semi-interquartile range. Okay. Now coefficient of quartile deviation, Q3 minus Q1 divided by Q3 plus Q1 into 100. Okay. Now there is one more formula. I'll tell you what is this one more formula. Now, my dear friends, quartile deviation is based on middle 50% of the observations. Now, if you see, I said you quartile divides the data into 4 parts. Each part will be of 25%. Now, quartile deviation, what is the formula? Q3 minus Q1, right? So, Q3 minus Q1 means it is falling only in this region. So, that's the reason I said quartile deviation is based on middle 50% of the observations. Next. Now, since it is based on middle 50% of the observations, it is best for open-end series. Now, you remember what is open-end series? If you don't remember also, there is no issue. I'll do one example now. Now, what I'll do one example for individual data. I'll do one example for continuous data. Then I'll teach you how this formula has come. Then we'll wind up the quartile deviation. We'll go for mean deviation. Okay. Now see here, my dear friends. I'm having 3 quartiles. Quartile 1 is 45. Quartile 2 is 52. Quartile 3 is 65. I want quartile deviation. What will be quartile deviation? Q3 minus Q1 by 2. That is 65. Minus 45 by 2, 20 by 2 is 10, right? Simple. This is how you will calculate quartile deviation. Yes, sir. This is how you will calculate quartile deviation. Now, one more example. This is your ICA question, what I have written just now. Okay. 56, 48, 65, 35, 42, 75, 82, 60, 55, and 50. This is the given data. I need to calculate the quartile deviation. So first what I'll do, my dear friends, I'll go ahead and arrange the data in ascending order. So let's arrange the data in ascending order. What the first observation? 35. Next, 42. Next, 50. 55. Oh, sir, 48 you missed. 48, 50, 55. Next, 56, 60, 65. 56, 60, 65. Next, 75 and 82. Right? Now, I want quartile 1. How will I calculate quartile 1? J into n plus 1 by 4. 1 into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus 1 by 4. 1 into 11 by 4. What is 11 by 4? I hope it is 2.25. Let's check. Yes, 2.75. It is 2.75. Is 2.75 the answer? No, it is 2.75 the observation. How will you get? Second observation plus 0.75 into third minus second. Second observation is 42 plus 0.75 into 48 minus 42. So 42 plus 0.75 into 6. So 0.75 into 6 plus 42. So it is 46.5. Okay. So I hope it's clear how to calculate quartile 1. You already know this. I calculated quartile 1. No, I'll give you 1 minute time. Calculate quartile 3 and tell. Both please calculate quartile 3 and tell me. Let me see whether you are telling correct or not. And whether you understood yesterday's session or not. No, Geeta, it's wrong. Please check it. Perfect, Vaishnavi. Okay, let us do. Geeta, please check your answer. J into n plus 1 by 4. So J, 3 into 10 plus 1 by 4. 3 into 11 by 4. Which is 8.25th observation. So it will be 8th observation plus 0.25 into 9th minus 8th. So 8th observation, 1, 2, 3, 4, 5, 6, 7, 8. 65 plus 0.25 into 75 minus 65. So 65 plus 2.5, 67.5. Okay. So we got quartile 1, we got quartile 3. So what will be quartile deviation? Q3 minus Q1 divided by 2, which is equals to 10.5. Okay. So I hope it's simple. There is nothing much difficulty in calculating this quartile deviation. Yes, sir. There is nothing much difficulty in calculating quartile deviation. Next. So this is, my dear friends, with respect to individual data. As I said, you already discrete data is useless. We need not focus much on discrete data. Now let's do one thing. Let's focus on continuous data. Okay. One sum on continuous data, and then we will be done with quartile deviation. Done and dusted with quartile deviation. This is there. No, this is not there. Example. Observations are there. Frequency is there. Question is find appropriate quartile. Find appropriate dispersion. This is the question. In the examination, he didn't say to calculate quartile deviation. He just said find appropriate dispersion. Okay. Now, the question is below 50, sorry, below 30, 30 to 39, 40 to 49, 50 to 59. It is not 60 to 69, it is 60 to 79 now. Okay. In examination, students will get confused. They'll take 60 to 69 and they'll solve. No, read the question carefully. Above 80. Okay. Now, frequencies are given somewhat like this. 5, 7, 18, 32, 28, and 10. These are the frequencies. These are observations. Now, my dear friends, he is asking you to calculate appropriate measure. If you look here carefully, when you are calculating appropriate measure, it's an open-end classification. You are having below 30, above 80. Means both the ends are open. Okay. Below 30, I don't know whether it's 0 to 30, 10 to 30, 20 to 30, 29 to 30. No. Above 80 means 80 to 19, 80 to 100, 80 to 1000 can be anything. Okay. One place we have below 30, one more place we have above 80. Okay. So, my dear friends, in this case, it's an open-end classification. And whenever you have open-end classification, there, my dear friends, the best measure is quartile deviation. Sir, why, sir? Simple, sir. Quartile deviation is based on middle 50% of the observations. So, quartile deviations fall somewhere in between. Since it is based on middle 50% of the observations, that's the reason quartile deviation is best. Yes, Geeta, it will be 60 to 79, not 60 to 69. Okay. Question gave like that. We can't do anything. Okay. It can be like this. There is no issue. There is no wrong. Statistics doesn't say that it is wrong. Okay. You can have 60 to 89 also. There is no rule that every time class interval length should be same. But this is the only question in your entire ICA material where class interval length is not same. Right? Everywhere class interval length is same. Okay. So only in one question you have to be cautious. Okay. Now it's an inclusive data, right? Let's convert to exclusive data. Below 30, 29.5, 39.5, 49.5, 59.5, above 80. 39.5, 49.5, 59.5, 79.5. Okay. Now, first I'll calculate quartile 1. For the first step, my dear friends, first step is LCF. Let's do LCF. 5. 5 plus 7. 12. 30. 62. 90. 100. Okay. Sum of frequency is also 100. Second step, you will do Jn by 4. 1 into 100 by 4, which is simply equals to 25. Locate in LCF. Can I say this is the place where you will be having LCF? Locate in LCF. When 25 is not there, what you will do? You will simply go for next highest value. Okay, locate in LCF. Then apply the formula. L plus Jn by 4 minus cumulative frequency of previous class, frequency of same class into class interval. L is 39.5. Jn by 4, 25. Cumulative frequency of previous class 12. Frequency of same class 18 into class interval 10. So 25 minus 12, you have 13 into 10 divided by 18. So 39.5 plus 7.22. So 46.72. Okay. So I hope quartile 1 is perfect, my dear friends. Now, let's go ahead and let's calculate quartile 3 now. Then we can calculate quartile deviation. This is Q1. I'll share the notes after the class today. Okay, so if you are missed writing anything, don't worry, you can copy from there. Let me erase this. Now, quartile 3. First step, LCF. Second step, Jn by 4. 3 into 100 by 4, which is fortunately 75. Now, locate it. It will fall here. Next, fourth, L plus Jn by 4 minus cumulative frequency of previous class, frequency of same class into class interval. Again, it depends on the L 59.5. plus Jn by 4. How much is Jn by 4? Just now we calculated, sir, 75. Cumulative frequency of previous class 62. Frequency of same class 28. Class interval is 20. Class interval is not 10. Class interval is 20 now. Be careful. So 75 minus 62 divided by 28 into 20. So 59.5 plus 9.285. 68.785. Okay, we got quartile 1, we got quartile 3. Now quartile deviation, Q3 minus Q1 by 2. 68.785 minus 46.722 whole divided by 2. So it is 11.03. Okay. Now, this question is given in terms of rupees. So answer also you'll write it in terms of rupees. Be careful, absolute measure should express it in units. Relative measure should express it in percentages. Okay. Now, quartile deviation we got 5. What is the formula for coefficient of quartile deviation? Q3 minus Q1 divided by Q3 plus Q1 into 100. Okay, for this question, I am not calculating coefficient of quartile deviation. If you want, you can calculate. That's your choice. Formula is same like ranges. Now, Q3 minus Q1 by Q3 plus Q1 into 100. What I am doing, numerator and denominator, I am dividing by 2. Numerator slash denominator divide by 2. So Q3 minus Q1 by 2, Q3 plus Q1 by 2. Now Q3 minus Q1 by 2. What is Q3 minus Q1 by 2? Quartile deviation. What is half of Q3 and Q1? Obviously Q3 plus Q1 by 2 will be quartile 2 into 100. What is quartile 2, my dear friends? Median, right? That's the reason the formula is quartile deviation divided by median into 100. This is how you got the formula for quartile deviation. One more formula for coefficient of quartile deviation. Okay. So I hope the points are clear. Quartile deviation. Where it is? It's here. So semi-interquartile range is called as quartile deviation. Let it be individual, discrete or continuous, formula will remain same. For quartile deviation, Q3 minus Q1 by 2. For coefficient of quartile deviation, Q3 minus Q1 by Q3 plus Q1 into 100. Next, I said you quartile deviation is based on middle 50% of the observations. Next, Q1, Q2, Q3. Q1 is lower, Q3 is upper, and Q2 is middle quartile. Right? Next, I said you quartile deviation is best measure for open-end series. Next, at last, I said you in central tendency, what is the best measure? Median is the best measure. In dispersion for open-end series, quartile deviation is best measure. In central tendency, median is best measure. Okay. So, my dear friends, you can see every point I have covered in this notes. There's no point what I have skipped. So, that's the reason many students before the examination, once they refer this notes for maths or stats, it's more than enough to clear the examination. Okay. Multiple revisions for maths and stats. Okay. Just little common sense and multiple revisions of formulas is more than enough to clear this paper. Okay. Let's go for the third one. Third one is little lengthy. Okay. I guess today whole time, I told you, I asked you for extra half an hour, right? Because yesterday and day before yesterday, we have winded up 15 minutes early. So today give me extra half an hour so that our syllabus will be on track. Okay. And we have only 24 days left for our examination. Assuming that examination is only in September 1st, not September 10th or 11th. Okay. So 2 measures of dispersion we have completed, total 4 measures of dispersion. Range, quartile deviation, mean deviation, and standard deviation. Now, range is difference between highest and lowest. Quartile deviation is semi-interquartile range. Now, range and quartile deviation, both, my dear friends, they are what measures? Positional measures. Because in range, I consider only highest and smallest. Next, in quartile deviation, I consider only middle 50% of the observations. Okay. Now comes this mean deviation and standard deviation. In mean deviation and standard deviation, what we'll do? We'll consider the entire data. Okay. There's no particular point what we leave. We'll consider the entire data. Now see this mean deviation, what he's trying to tell. He's telling arithmetic mean. What is arithmetic mean? Sum of observations by number of observations. Of absolute deviations taken from mean, median, mode. He's telling arithmetic mean of absolute deviations taken from mean, median, and mode. My dear friends, this mean deviation can be calculated either from mean or from median or from mode. Okay. He's telling arithmetic mean. How will you get arithmetic mean? Sum of observations by number of observations. Sum of observations by number of observations. Sum of observations by number of observations. He's telling arithmetic mean of what? Absolute deviations. Do you remember yesterday I said you absolute deviations? What do you mean by absolute deviations? Don't take a negative sign. Okay, if you don't take negative sign, that is called as absolute deviation. You remember this? Sum of deviations from arithmetic mean is 0. Sum of square deviations from arithmetic mean is minimum. Sum of absolute deviations from median is minimum. Right? Same way, the arithmetic mean of absolute deviations taken from mean, median, mode is called as mean deviation. Absolute deviations, deviations where negative symbol is equal. How will you calculate deviation? X minus x bar, x minus median, x minus mode. Okay. So this is mean deviation taken from mean deviation taken from median, mean deviation taken from mode. I hope that's fine, everybody. 3 different formulas. Now, this is for individual data. Now, how will you calculate coefficient of mean deviation? Coefficient of mean deviation will be, you have calculated mean deviation from mean, will be mean deviation by mean into 100. Calculated from median, mean deviation by median into 100. If you have calculated from mode, mean deviation by mode into 100. Let's see a few examples for this. And then let's go for the next point. Examples. 3 examples I'll solve. 2 examples you will solve now. Then we'll go for continuous data. Discrete data is chiller. Mean deviation about mean of 58634. What is the formula for mean deviation about mean? Sum of modulus x minus x bar whole divided by n. So if you want to apply this formula, first you require x bar. Without x bar, what you will calculate? We can't calculate. So first let's calculate no x bar. How will you get x bar? Sum of observations by number of observations. Whole divided by 5. 5 plus 8 plus 6 plus 3 plus 4 by 5. 5.2. Now, x minus x bar. What is 5 minus 5.2? 0.2. My dear friends, don't take negative symbols. Modulus is there. 8 minus 5.2. 2.8. 6 minus 5.2. 0.8. 3 minus 5.2. 2.2 plus 1 point. Whole divided by 5. 0.2 plus 2.8 plus 0.8 plus 2.2 plus 1.2. Whole divided by 5. So 1.44 is the answer. This is mean deviation about mean. What about coefficient of mean deviation? Mean deviation by mean into 100. 5 divided by mean because you have taken from mean. 1.44 whole divided by 5.2 into 100. %27.69%. Okay. So I hope mean deviation about mean is clear. Now, mean deviation about mode. One more example, second example. How will you calculate mean deviation from mode? Let's see. Question he gives somewhat like this. 4 by 11, 6 by 11, 8 by 11, 9 by 11, 12 by 11, and 8 by 11. Okay. Now, mean deviation about mode he is asking. First, I need to calculate mode, right? What is mode? 8 is repeated 2 times. So, 8 by 11 is the mode. So, mode formula is summation of modulus x minus mode by m. So, let's calculate x minus mode first. Now, what is 4 by 11 minus 8 by 11? 4 by 11. 6 by 11 minus 8 by 11? 2 by 11. 8 by 11 minus 8 by 11 is 0. Sir. Plus 1 by 11. 12 by 11 minus 8 by 11? 4 by 11. Plus again 0. Sir. 4, 5, 6, 7, 11. So 11 by 11, which is equals to 1. Okay. So 1 whole divided by 1, 2, 3, 4, 5, 6. 1 divided by 6 is the answer. Okay. So mean deviation taken from mode is 1 divided by 6. I hope you understood the concept. Now let me give you 2 questions. Go ahead, solve them and tell me the answer. Then we'll go for continuous. Okay. Not 3 questions I'll give. Example. Mean deviation about mean of first 9 natural numbers. Example. Mean deviation about mean 50, 60, 50, 50, 60, 60, 60, 50, 50, 50. Oh my God. This many numbers he gave. 60, 60, 60, 50. Okay. One more question, one more question. Next. Mean deviation about median. (82, 56, 75, 70, 52, 80, 68. So 3 questions. I'll give you 5 minutes. Complete them and tell me the answer. So let's get the solution for this. He's telling mean deviation of mean for first 9 natural numbers. What are the 9 natural numbers? What we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 9 natural numbers what we have. So if you see, this is the mid value, right? This is the arithmetic progression. So mean will be equals to mid value, that is 5. Even if you do 1 plus 2 plus 3 plus 4 plus 5, so on, even there you will get the same answer, 5. Okay. Now, summation of modulus x minus x bar by n. 1 minus 5, 4, 2 minus 5, 3 minus 5, 4 minus 5, 5 minus 5, 6 minus 5, 7 minus 5, 8 minus 5, 9 minus 5. Whole divided by 9. So 20 divided by 9. 20 divided by 9, 2.2. Okay. You can even apply this formula also. Mean deviation of first n natural numbers. 9 square minus 1 by 4 into 9. 9 square 81 minus 1 by 4 into 9. 80 by 4 into 9. 4 ones, 4 twenties. 20 by 9. Okay. Next. Mean deviation about mean. First, let's calculate mean. How many times 50 is repeated? 1, 2, 3, 4, 5, 6, 7. 60. 1, 2, 3, 4, 5, 6, 7. 50 is repeated 7 times. 60 is repeated 7 times. 50 plus 50. 1, 2, 3, 4. I'll do one thing. 5, 6, 7. 60 is also repeated 7 times. 60 plus 60. 1, 2, 3, 4, 5, 6, 7. Divided by 14. 770 divided by 14, which is 55. Now summation of modulus x minus x bar by n. What is 50 minus 55? 5. 60 minus 55? 5. Everywhere 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Whole divided by 14. 70 by 40, which is equals to 5. Okay. So example 2, it's 5, not 10. Please correct it. Next. What about example 3? Let's check. It's not in ascending order, right? First, let's arrange it in ascending order. 52, 56. Next, 68, 70, 75, 68, 70, 75, 80, 82. What's the mid value? 70 is the mid value. So median is 70. Okay. So summation of modulus x minus median by n. So 52 minus 70, 18. 56 minus 70, I hope 14. 2, 0, 5, 10, 12. Whole divided by 7. Let's check the total. 18 plus 14 plus 2 plus 5 plus 10 plus 12. 61 by 7. 8.714. Okay. So I hope 3 examples are clear. Total, we have done 6 questions on individual data. That's more than enough on individual data. Okay. Now, my dear friends, let's go to continuous and discrete data. See, in this, what is the formula for mean of discrete data? I hope you remember. So, my dear friends, mean of discrete data formula is summation of f into x whole divided by summation of f. Summation of f into x whole divided by summation of f. Summation of f into x whole divided by summation of f. But here, now don't cancel summation of f and summation of f. That's nonsense. In between, something is there still. Sigma is there, you can't cancel like that. Here you'll have x minus mean, x minus median, x minus mode. Okay, because you are doing mean of absolute deviations. So be careful. Next. In this case, my dear friends, instead of x over here you have x, right? Instead of this x, I'll have m. Instead of this x, I'll have mid value. Instead of this x, I'll have the mid value. Okay. Let's do one question on continuous data. One question will be for your homework. One question I'll solve now, and then let's wind up. And be careful, coefficient of mean deviation. Don't forget this. Mean deviation by mean deviation by median, mean deviation by mode into 100. One question I'll solve. Fine. Yes, sir, it's fine. Let me solve a lengthy one. One lengthy one I'll solve. Then 1-2 questions will be for your homework. Then we'll wind up this mean deviation and then we'll start with standard deviation. Okay. It's a little lengthy sum. Okay. So that all the concepts, earlier concepts will be covered. See, this much lengthy he'll not ask in the exam. It's ICI material sum, so it is a little lengthy sum. Okay. Because 1 mark he can't ask so much in the examination. Okay. I'm asking find mean deviation about median. So observations are given, frequency is given. So observations are given as 131 to 140, 141 to 150, 151 to 160, 161 to 170, 171 to 180, 181 to 190. Frequency is given somewhat like this: 3, 8, 13, 15, 6, 5. Is asking you to calculate mean deviation about median. So can you see it's a continuous data, right? Okay. Continuous data, what will be the formula? Summation of f into modulus m minus median whole divided by summation of f. This is the formula. So first what we'll do, my dear friends, we'll calculate median. But can you see, unfortunately, this is what data? Inclusive data. We are supposed to convert it into exclusive data first. See that exception is there only to mean, not to median. Exclusive data. Exclude. 130.5, 140.5, 150.5, 160.5, 170.5, 180.5. All lower values minus 0.5. All upper values plus 0.5. 140.5, 150.5, 160.5, 170.5, 180.5, 190.5. Okay. Now, first, my dear friends, let's compute median. How will you compute median? First step is LCF. So let's go ahead and let's calculate LCF. 3. What is 8 plus 3? 11. 11 plus 13? Obviously, it's 24. 24 plus 15? 39. 45. 50. Total is, let me check. 3 plus 8 plus 13 plus 15 plus 6 plus 50. First step is LCF, that's completed. Second step is you'll do n by 2. 50 by 2, which is equals to 25. So located in LCF, where it is in LCF, it is somewhere around here. What happened to this? Running away result. Come back. Third point, you will locate. I located it. Next, fourth point, you will apply the formula L plus n by 2 minus CF divided by F into class interval. L 160.5, n by 2 25, cumulative frequency of previous class 24, frequency of same class 15, class interval is 10. Okay, let's calculate it. 25 minus 24, 1 into 10 divided by 15 plus 160.5. So it is 161.1666. 161.1666. Simple. Let's apply this formula now. But before applying this formula, you want mid value. Without mid value, what you will apply? So let's calculate mid value first. How will you get the mid value? I hope you remember. Lower class boundary plus upper class boundary whole divided by 2. 135.5. Lower class boundary plus upper class boundary whole divided by 2. 145.5. 155.5. 165.5. 175.5. 185. Okay. Now, mid value minus median. Mid value minus median. Don't forget modulus is there. Let me take only till 2 decimals. It's enough. 161.16. 135.5 minus 161.16. 25.66. 15.66. 5.66. 165.5 minus 161.16. 4.34. 14.34. 24.34. Yeah, 5.66. Now, F into M minus median. Now, this multiplied with frequency. Now, what I'll do, I'll use M plus directly. You can also use M plus. I'll not do individually. Time waste again. 25.66 into 3 M plus. 15.66 into 8 M plus. 5.66 into 13 M plus. 4.34 into 15 M plus. 14.34 into 6 M plus. 24.34 into 5 M plus MRC. This one total is 548.68. Okay. So formula summation of F into M minus median whole divided by M. So summation of F. 548.68 whole divided by sum of F50. That is 10.9736. That's it. Okay. So first you calculate median, then you apply the whole nonsense, then you will go ahead and you will get the answer. Observation is given in cages. Final answer is also in cages. Okay. Now, one question is homework. I'll share that question in your group. Just solve it today. I hope discrete data you can do it. I'm giving one discrete data question and one continuous data question. I'll share it in the group. Give me 1 minute time. Question 1 and question 3 homework. Okay, I've shared it in the group. Question 1 and question 3 is your today's homework. So that's all regarding mean deviation, my dear friends. We have seen mean deviation for individual data. We have seen mean deviation for continuous data. We did not see mean deviation for individual data. That's of no use. For discrete data, that's of no use. However, one question I have given in the homework. See, 3 questions I have shared. If you have time, solve the 3. If you don't have time, solve first and third one. That's more than enough. Okay. Now, let's come to standard deviation. See, this common properties of entire dispersion I've given after standard deviation. Okay. So you'll not worry about that. If you haven't written, it's completely fine. I've given one example also. Okay. Now let's come to standard deviation, my dear friends. As I said you already, in any foreign courses you study or in any internet very advanced statistics you study, whenever they say dispersion, they say standard deviation. Okay. See, exact financial derivation of standard deviation, I can't teach you because for that you should have financial background knowledge. Okay. This is just a little technique what I teach you. Okay. That much is enough for your examination because only that much is there in your book. Okay. So how much is there? Only that much I can teach. But what is exact definition of standard deviation? All those things you'll go ahead and you'll understand in your CA into financial management. So here deep, I'm not diving into this, but standard deviation is very much important. Okay. Because if you understand standard deviation, then only you will understand correlation and regression. Okay. You should understand how to solve standard deviation so that you will understand correlation and regression. Okay. Again, same standard deviation we'll be using in probability also. Because after index numbers are completed, I'll take a probability. What I said you already. Introduction, central tendency and dispersion, index numbers, probability. These 4 chapters alone, 20 plus 5 plus 7. These 4 chapters alone comprise of 32 marks weightage in statistics. So first our focus will be to complete these 4 chapters. Already TVM is completed, extra 13. So you'll be done with 45 marks. Once these 4 chapters are completed, you'll be done with 45 marks. Then 20 marks LR. So in 10 days, you can clear QA. Okay. We are studying for 10 days and we are clearing QA and you don't believe me. There are few girls, few boys who have done this. Okay. I know one girl who prepared for 62 marks. She went to the examination. She wrote 62. She got 60. She cleared that attempt. Then she couldn't clear for 2 attempts only because of this exam, mathematics exam. Okay. Let's start. Standard deviation. This is there. So what is the standard deviation? Root mean square deviation taken from mean is called as standard deviation. Now, he's telling root. How will you get mean? Sum of observations divided by number of observations. Mean of what? Mean of square differences. Square differences from mean. Mean of square differences from mean. Under root sum of x minus x bar whole square by n. This is standard deviation, individual data. In case of discrete data, here I'll introduce f. Summation of f into x minus x bar whole square by summation of f. In case of continuous data, instead of x, I'll have mid value. Okay. Now, my dear friends, let you use this formula or this formula, answer will remain same. These are called as easy formulas. Under root summation of x square by n minus mean square. Any formula you use, you are going to get the same answer. Okay. So predominantly in examination, mostly individual data will be asked and compared to discrete data and continuous data. Okay. See here how to compute standard deviation. Now I'll tell you once few simple 2-3 examples of standard deviation also where you can use, like, which helps you to understand the real logic behind standard deviation. But exact logic, everything you'll understand it in financial management. Because in FinStats, we use this. That is financial management, which is done with statistics, FinStats. There you'll be using this financial modeling, all the spaces. Now let us take an example. I'll show you two formulas application. It's asking find standard deviation of 5, 5, 9, 9, 9, 10, 5, 10, 10. Okay. What is the second formula, my dear friends? Under root summation of x square by n minus mean square. First, let me apply second formula. Okay. What is the mean here? 5 plus 5 plus 9 plus 9 plus 9 plus 10 plus 5 plus 10 plus 10. I hope 9 observations are there. Let me calculate. $72 by 9. I hope x bar is 8. Okay. Now, summation of x square. 5 square 25, 5 square 25. 9 square 81, 9 square 81, 9 square 81. 10 square 100, 5 square 25, 10 square 100 plus 10 square 100. 300 plus 75. 680. So under root 618 whole divided by 9 minus mean square. What is 8 square? 64. So under root by 9, which is 68.66 minus 64. Under root 4.66. What is the root of 4.66? Obviously, sir, 2.160. Okay. So what is the standard deviation here? 2.160. No options what he gave? 42 he gave. In options he gave root of 42 by 3. Array 2.160 root of 42 by 3 both are same. There's no change. Okay. Don't ask again, sir. Option not matching. No, it will not match. Okay. So I hope it's clear using second one. Now let me solve. Let me take one question and there I'll solve it using the first one. 1 minute. Where is the standard deviation? You know, whenever I say standard deviation, people look very as if it's a very scary thing. After this, I'll give you one question which you will solve. In the next question, what I'm giving you, you wish apply any technique, any formula. Example 58926. I need to calculate standard deviation. Under root summation of x minus x bar whole square by n. First x bar 5 plus 8 plus 9 plus 2 plus 6 whole divided by 5. 5 plus 8 plus 9 plus 2 plus 6 whole divided by 5. 6. Now, x minus x bar whole square. 5 minus 6, 1. 8 minus 6, 2. 9 minus 6, 3. 2 minus 6, 4. 6 minus 6, 0. 1 plus 4 plus 9 plus 16. 30. Root of 30 by 6, which is equals to root 5. Okay. So I hope the point is clear how to calculate standard deviation. I have applied two formulas for standard deviation. I have applied a first formula as well as second formula. Okay. Now, my dear friends, I hope you understood what is standard deviation. I'll tell you exact definition also. Don't worry. Not today. I think I'll tell it tomorrow. Okay. Now, what is coefficient of standard deviation or coefficient of variation? Coefficient of standard deviation or coefficient of variation will be standard deviation divided by mean into 100. Okay, this is going to be coefficient of standard deviation or coefficient of variation. Now, let me give you one question. I want you people to solve that question. Example. I'll wait for 5 minutes. Please solve it and tell me. Last question for the day. After this, one small concept is there. I'll tell you that and we'll wind up. $53, $52, $61, $60, $64. Calculate standard deviation, calculate mean, coefficient of standard deviation or variation. How will you calculate? Standard deviation divided by mean into 100. One small suggestion I'll give you. If possible, apply this formula. Okay? Apply this one. Possible, please apply this formula. Okay? I'll wait for 5 minutes, not 5 minutes. 4 minutes is enough. Please solve it and tell me the answer. Chalo, my dear friends, let's continue. First time you also send it once, but I'll see where you are made a mistake. Next. Now, let me solve this. It's asking standard deviation. Okay, we have standard deviation and the coefficient of standard. Okay, let me see. Standard deviation, x bar, and coefficient of standard deviation he is asking. Let us solve it. Now, first x bar, how will you get x bar? 53 plus 52 plus 61 plus 60 plus 64 whole divided by 5. 53 plus 52 plus 61 plus 60 plus 64 whole divided by 5. It is equals to 58. Now, under root summation of x minus x bar whole square by n. Now, let me compute summation of x minus x bar whole square. 53 minus 8, 5. 52 minus 58, 6. 61 minus 58, 3. 2. 6. 5 square plus 6 square. 5 square 25 plus 36 plus 9 plus 4 plus 36. Next, 25 plus 36 plus 9 plus 4 plus 36. 110. So, under root 110 divided by 5. That is root 22. So, coefficient of standard deviation will be root 22 by mean 58 into 100. So, 8.09 approximately. Okay, or 8.08. Okay, so please check your answers once. So, coefficient of standard deviation will be 8.09%. Okay, so that's it, my dear friends. Tomorrow we'll wind up standard deviation, and there are some questions which I'll share with you. 1-2 days, just sit on this central tendency and dispersion. Okay, because it has 13 marks weightage. So make sure that you'll complete those sums. All our previous year questions. ICI material, no need to do anything because all the questions in ICI material I'm already covering in the class. Okay, that's it. Balance things. We'll see tomorrow.